Hey guys, this is Ellen Pekarski. This is the review for the test that you're going to have on Monday. We're going to have several things covered in this test, and I'm just going to go through the review and talk about the different equations that you need to know about. The first problem has a scenario where you are walking across a flat land. You notice an oil derrick, and they have a picture. And then from ground level, the angle of elevation to the top is 35 degrees. After walking 50 feet closer to the oil derrick, the angle of elevation changes to 40 degrees. Find the approximate height of the tower round to the nearest tenth. Okay, so this is the rough sketch. I prefer to just get rid of the tower and deal with triangles. We're looking for this side, the height of this side. But before we find this side, we have to know the length of this side here. And just from the wording on the word problem, I've set up the diagram. So from here, our elevation was 35 degrees. So this angle right here is 35 degrees. And then we walked 50 feet. So from this point to this point is 50 feet. And then our angle of elevation is 40 degrees. So here's our angle of elevation here. With the property of supplementary angles, that makes this angle here 140 feet or 140 degrees, excuse me. And then that means that this third angle here is 5 degrees because the three angles inside a triangle have to equal 180. All right, so that we know. We also know that the tower is standing straight up. At least we hope it is, or else it's major problems with the oil spills and all that fun stuff. So we're going to assume that the tower is standing straight up. So it's a 90-degree angle here with this 40-degree angle here. Then this is a 50-degree angle here. All right, so those are all the knows. Now we need to figure out how to find our y value here. So we're going to use the law of sines. We can set it up as 50 because this side angle is, or this side is opposite of this angle here. So our side is 50 divided by sine of 5 degrees here is going to be equivalent to the ratio of side y divided by sine of 35. You're going to solve for y by multiplying this side by sine of 35. You plug it into the calculator, you get this big number. And that's what your y value is. And so now we're ready to find our opposite side. And so you can do that with the ratio of sine, SOHCAHTOA. So for sine, it's opposite over hypotenuse. We now know the hypotenuse is 319.05. The opposite side, I just labeled x. That's the side we're looking for. So we're going to multiply both sides by 329. And when we plug that into the calculator, we're going to get our x value. And in this case, we got 211.51 feet. Okay. And that is just with using law of sines and our trig ratios. All right, now we have a angular linear velocity. Let's see which type it is. We have the second hand on a clock is 5 inches long. So this red line here is 5 inches. Approximately how far does the tip travel in 3 minutes and 15 seconds? So it makes, for 3 minutes, it does 1 revolution per minute. So for 3 minutes, it's doing 3 different revolutions. So that's where the 3 here comes from. And then another 15 seconds. So after the 3 revolutions, we make it another quarter of a rotation. So that's where we get 3.25. If this said 3 minutes and 30 seconds, then it would be 3.5 because 30 seconds is the half of a rotation. So that's how we're getting our rotations. Okay, and then so this formula for linear velocity, we're looking for the distance. So this is for arc length, not linear velocity, excuse me. So for arc length, we have to have our angle in radians. So this is our rotations. and there are 2 pi radians in each rotation. So we're multiplying the 3.25 by 2 pi to get our angle in radians. And then we're also multiplying by the radius, which is 5 inches, and that tells us how far this tip has traveled, and that's in inches. Okay. Here's another problem that has to do with arc length. We have a city in San Antonio is at 29.5 degrees from the equator. Mexico City in Mexico is 20 degrees from the equator. And our radius of the Earth is 4,000 miles. And we want to find the distance between these two cities. So these two cities here, and that is again going to be arc length. So we want to know our angle. And so we're just taking this degree minus this degree to give us this tiny degree here, our angle here. Then we have to convert it to radians. So we're multiplying our degrees by pi and dividing by 180, and then multiplying by our radius, and that's how we get our distance between the two cities. Okay, sector area. Ooh. To find the area of a sector, it's 1/2 times our angle in radians times our radius squared. That is the formula to find the sector area. And so we have our angle 64 degrees. We have to convert it to radians, so multiply by pi, divide by 180. Here's our 1/2. That's just part of the equation to find this sector area. And then our radius squared is here. We plug it all into the calculator, and we get this number of centimeters. Centimeters squared. All right. I have a triangle here, but sometimes it's honestly really confusing to look at the image. I just wanted to show you that in this example, this line here is exactly the same length as this line here. So in this image, it's possible to have 2 different triangles when you're only given one of your angles, 1 and 2 of your sides. Okay. So for the ambiguous triangle scenario, there's 3 possible situations. You could just have one possible solution, you could have 2 possible solutions, or you could have just no solution at all. And so you just have to set up your trig law of sines ratios and plug it into the calculator and see what the calculator gives you. So in this case, we have angle A is 72 degrees, side A is 3, and side B is 21. And so you set up your trig ratios like this. We have our angle A, we have our side A, we have side B, and we're looking for angle B. And again, anytime you're looking for an angle with this, you have to do inverse sine of all of this. For this ratio here, we just cross multiplied and divide. So you multiply those two together and then divide by 3 and solves for sine B. We did inverse sine of 21 times sine of 72 divided by 3. That would give us our B value. When we plug that into the calculator, we get undefined. And the reason why is because this side measurement is way too small to be associated with this size of degree, side of angle. Okay, so in this scenario for our ambiguous triangle, there's no solution. Okay, the next alternative, let's say we switch the 21 and the 3. So side A was 21 inches, centimeters, whatever it says. Oh, it just says units. Okay, so side A, if a side A was 21 units and side B was 3 units, again, we would cross multiply and divide, do the inverse sine, plug it in, and the calculator tells us that our angle is 7.8 degrees. Okay, now to check to see if we have a second possible solution, we're going to take our first possible answer for angle B, subtract that from 180. That gives us our second possible angle for angle B. Okay, but if we add our angle A to our angle B and it's greater than 180, then we cannot have a second possible angle. Okay. third scenario is this one. Totally different numbers this time. I have 4. My side A is 4, side B is 5, angle A is 36, and again I'm looking for angle B. Cross multiply and divide, inverse sine. We find angle B is 47.3 degrees. Now we check to see if it's possible to have a second possible triangle by taking this 47.3, subtracting it from 180. That gives us our second possible angle. We add the second possible angle to our original angle A up here, and that gives us 168.7 degrees, which is less than 180, so it is possible to have a second triangle. Okay. On the test, I don't know which version of the test you're going to get, so I don't know whether you'll have a scenario where there's no solution, just one solution, or 2 possible solutions. All right, let's move on. We have a baseball diamond. The distance between the pitcher's mound and home plate is 60.5 feet. We've got a 45-degree angle here, and this distance from home to first base is 90 feet. And we want to know, so if the pitcher gets the ball, how far does he have to throw it from the pitcher's mound to first base to get the person on first base out? Okay, so we're looking for this side measurement here. And with the information we have, we cannot use the law of sine. We have to use the law of cosine. So we're going to just put an X for this side measurement. These are the other 2 side measurements, and we're going to use cosine of 45 degrees. So here we have X squared is our one side measurement squared plus the other side measurement squared minus 2 times one side measurement times the other side measurement times cosine of 45 degrees. Everything on the right side we multiply, combine just plug it all into the calculator. We get 4,059.86 feet. Okay. Now to find out what X is, we're going to square root that, and we get 63.7 feet, 72 feet. Okay, so that's how far it is from the pitcher's mound to first base. All right, a pulley is turned 60 degrees per second. Find the number of revolutions per minute. This one, we're just checking to see if you remember how to convert units of measurement. So when you do this, whatever unit you're trying to get rid of, if that unit is in the numerator, then you're going to put the next unit, the same unit of measurement in the denominator. If your unit of measurement is in the denominator, to cancel out that unit of measurement, you're going to put it in the numerator. All right, so here we go. We're looking for revolutions per minute. We want to get rid of degrees, so we're going to put degrees in the denominator. And we want revolutions, so we're going to put revolutions in the numerator. And in this case, in one revolution, there's 360 degrees. So that's how we got 360 here. And then we want to convert from seconds to minutes. So seconds started off in the denominator. We're going to put it in the numerator to cancel out the seconds. And there are 60 seconds in 1 minute. This degree cancels out that degree. This second cancels out that second. And we're left with revolutions and minutes. We multiply straight across in the numerator. We get 3,600. Multiply straight across in the denominator, you get 360. Divide that, you get 10 revolutions per minute. Okay, now we have a situation that applies to this, to number 7, but it does not, you do not need this answer from number 7, just the information from up here. If the radius of the pulley in the previous question is 7 inches, find the linear velocity in inches per second. Okay, for linear velocity, we have to have our angle in radians instead of degrees. So I'm converting from from degrees into radians. So multiply your degree by pi, divide by 180. That reduces to pi over 3. And I just realized I did not calculate this out. Let me see if I can find it in my phone really quickly. At the very least, I'll have an approximate value. So 3.14, 159, 265, 358. times 60 and then divided by 180. Okay, and then times it by 7. We get, you guys would probably plug this all into your calculator anyway, approximately 7.33, and then that is inches per second. They're thinking I'm doing secant. All right, inches per second. There we go. So that's your approximate answer. Again, the 10 revolutions per minute does not go anywhere in here. Okay, we're going back to the 60 degrees per second is what we're starting with. All right, on to number 9. So with triangles formed between the 3 polygons, has adjacent sides. So we have this shape. Notice nothing is labeled, and it really doesn't matter. So this could be 15, 23, 32. It really doesn't matter. We want to find the area between the 3 polygons. In order to find the area, we're going to do that 1/2 times one side length times the other side length times, hold on, I'm remembering, times sine of your angle that's not associated with the other 2 side lengths that you're using. Okay, so the formula for is area is 1/2 times one side length times the other side length times the angle that's in between these 2 side lengths. Okay, so remember the angle is associated with the opposite side here. So if I have these 2 side lengths and this angle, then I can find our answer. So I just randomly decided to put 15 on the left side, and we're looking for cosine of x, we're looking for x. Okay, in this case, guys, if you get this wrong, it's because you don't do your PEMDAS backwards correctly. Okay, so initially multiply these 2 together, then subtract it all. So 23 squared plus 32 squared is 1,553. And then 2 times 23 times 32 is 1,472. Okay. I have a lot of people that like to just go ahead and subtract these 2 from each other. That's not how you do it. You have to subtract 1,553 from both sides of your equation first, and then you're dividing by this because this negative 1,472 is multiplied by cosine. So you got to divide by that. Okay, then you want to do inverse cosine to find your angle x, and you do all that work and the calculator tells you it's 25.5 degrees. And then now we can go ahead and use the area formula with sine function. 1/2 times one side measurement times the other side measurement times the sine of the angle that you have. You plug it all into the calculator and you get 158.75 feet squared. And that gives us the area of our triangle. All right, a couple more problems. Find the value of x, round to the angle to the nearest tenth of a degree. Okay, so for this angle, we have the opposite and the adjacent side, which is our tangent ratio. So because we're looking for the angle, we're going to do inverse tangent of our side measurements. Here's your opposite over adjacent. Plug it in, push enter, you get your answer in the calculator. This problem here, this time we're looking for our side measurement, and this is our right angle here. And let me see, so we have the opposite side over the adjacent side. So again, we're going to use tangent, and it's going to be a tangent of 20 degrees is x divided by 8. And then so to get x by itself, we multiply both sides by 8. And so it's 8 times tangent of 20 degrees. Plug that into your calculator. I have no idea why I have that degree symbol. That does not look right. It's kind of funny because I don't think anybody in class said, hey, Miss Pye, that answer doesn't look right. Let me see what I did with it. Oh, yay, I do have tangent of, Let me clear this. All right, tangent of 20 degrees times 8 is equal to, I have no idea why nobody said, hey, Miss Pi, that's wrong. 2.91 units. Okay. So that's our answer from our calculator. 8 times tangent. The biggest thing here, I might move some of these values around, so you just need to know SOHCAHTOA and your trig ratios to know which trig function to use. All right, converting degrees to radians, we've done this a million times. In this case, you get 3 pi. Most likely your answers will not be in decimal form. They will have the pi symbol. So, and then convert from radians to degrees. So here's our radians. We multiply by 180, divide by pi, and we get our degree. Number 14, a 50 centimeter pendulum in a grandfather clock swings on a 12 centimeter length arc every second. So here's another arc length problem. In 1 second, how many degrees does the pendulum move? So we're just looking for our angle here. So for arc length, the formula equals your radius times theta, and your angle theta needs to be in radians. And so that's pretty much what we're looking for is our angle. We have our length is, arc length is 12. So we put the 12 centimeters here. Our radius is 50 centimeters. And now we're looking for our angle. We divide both sides by 50. We get theta is equal to 0.24. But this is in degrees, or excuse me, this is in radians because our formula is in radians. And then we need to take our radians, multiply it by 180, divide by pi, and that gives us our angle of 13.8 degrees. Find two solutions in the intervals between negative 90 degrees to 270 degrees. This time they give us a cosine problem, a tangent problem, and a sine problem. It's best if you remember with your solutions, your calculator is only going to give you one, and you need to know for the other possible solution, if you're dealing with cosine or secant, whatever your answer is from your calculator, it's just negative or positive. If you're dealing with tangent or cotangent, you're going to add or subtract increments of 180 to the answer the calculator gives you. And you just need to be aware of your limitations up here will determine whether you're adding or subtracting 180. And then for sine, the rule is whatever your first answer is, that's your first solution. Second solution is going to be 180 minus your first solution. Okay, so I think, let's see, yeah, we just set up the inverse cosine here, got the answer, found the second answer. Inverse tangent here, plugged it into the calculator, got our first solution, and we added 180 to get 236, which does fall into our limits from the instructions up top. If we tried subtracting 180, it would be outside of our limits. And then for sine function, again, inverse sine of that gives us those degrees. Because it's sine, we're subtracting our first answer from 180, and that's our second answer. And then the last possible problem that you'll have on the test, suppose angle F terminates in quadrant 4, and tangent of F is equal to negative 4 over 3. Find sine F and cosine F. With this, you need to be able to find your y value, your x value, and your r value. If you're in quadrant 4, then your y value is negative and your x value is positive. So this negative is associated with your y value, and x is going to be 3. You square those, add them, and then square root them to find your radius just from the Pythagorean theorem, and you get the r value is 5. So then just set up your trig ratio. So sine of f is y over r, so negative 4 over 5, and cosine of f is x over r, so 3 over 5. And that is the end.